All right, here we go. Question 29 from our Calculus 1, homework number 1 in WebAssign. We have an application problem. It says crystal growth furnaces are used in research to determine how best to manufacture crystals used in electric components. For proper growth of a crystal, the temperature must be controlled accurately by adjusting the input power. Suppose the relationship is given by, so they've given us a function where T of W is the temperature and W is the power in watts. And I am actually going to skip part A for right now. I've already done it, but we're going to come back and show how to get that answer. And what I want to do is do the easy stuff first. So part B, it says if the temperature is allowed to vary from 202 degrees Celsius by up to plus or minus 1 degree Celsius, that is epsilon. That is how much we're allowed to vary up or down from the target temperature of 202. So, taking all of this into account, part C says, in terms of the epsilon delta definition of the limit, they want to know what does the x represent. Well, if you notice right here, x is the independent variable of the function. In this case is w, which is power. So x is the input power. It is not the target input power, that's A. X is whatever the input power is. Okay, if we scroll down, A is the target input power because that's what the watts is approaching. The W, the X in this case, is watts. Power is approaching A. So A is the target input power. All right, what is f of x? Well, remember in this case, f of x is the temperature based on the power. And so if we scroll down and look at our options, f of x is y, which in this case is temperature. It's not the target temperature. F of x represents the actual temperature depending on what the power is, okay? L is the target temperature. L is the temperature that we're approaching, so it's the target temperature. And so that does it for the multiple choice questions here as far as identifying the components of the limit and what they represent. And if we read further, it says what value of epsilon is given. That was our plus or minus 1 degree Celsius. So epsilon in this case would be 1 degree Celsius that we're allowed to vary above and below 202 degrees. Now I'm going to submit those and see if those answers are correct. And then we'll look at solving the other pieces that I didn't address. All right, and if we scroll down, we can see that all of the answers that we just input, including the value of epsilon, those are all correct. And so now we're going to come back and we're going to look at how to answer part A, B, and the corresponding value of delta. Okay, so part A says how much power is needed to maintain the temperature at 202 degrees Celsius. They do want us to round our answer to 2 decimal places. Notice I've already done this to make sure I got it correct. Now I'm going to show how to get that. So our target temperature of 202, we're going to replace T of W right here in our function with that temperature, and then we're going to have to solve for W. And we're going to do that over here in our scratch pad. So here we go. 202 is our y value. Notice that this is a quadratic equation. And so in order to solve a quadratic, we first have to set it equal to 0. So we're going to start by moving the 202 to the other side, which makes it minus 202. And then we've got 0.1 w squared plus 2.157 w minus 182. And then we're going to identify the values of A, B, and C so that we can plug into the quadratic formula. And here we go. Solving for W, that's going to be negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. And then I'm going to use my calculator. Using the fraction button, we are going to have to do the plus and the minus both, and we will do those separately. So doing the plus first, we have plus the square root of, and I just noticed that I didn't write the squared. That would have been a tragic mistake. 2.157 squared minus 4 times 0.1 times negative 182 all over 2 times A. And if we hit equals, we get our 33.22 rounded. Equals 33.22. And then we would need to do the negative. On the Casio, we can delete the plus and do a minus without having to type the whole thing over again. Notice we get a negative answer this time, so that means the second solution is irrelevant. It's extraneous because you can't have negative power. And so that's how we ended up with the 33.22 watts. Next, for part B, if the temperature is allowed to vary by plus or minus 1 degree Celsius, they want to know what range of wattage is allowed for the input power. Round your answer to 2 decimal places. So now we're going to have to go back to our scratch work and redo all of this work we just did, but the target temperature is going to be plus or minus 1 degree Celsius. So to show you how that's going to affect the problem, the lower temperature then would be allowed to be 201, and then we would need to do all of this work over again and solve for W. And so I'm going to go through and just edit. So instead of negative 182, that's going to be negative 181. And then with my calculator, making sure I switch back to a plus, all I have to do is edit my value from 182 to 181. And I'm going to get 33.10 is my lower x. Let's call that x1, or actually it's w1. And then we're going to change from 201 to 203. That would be plus 1 degree Celsius. Making that 20 minus 203 is going to change this to 183. And then editing this to negative 183. And editing the input on my calculator to negative 183, we get 33.33. And when we input our answers for part B, we need to make sure that we put the smaller wattage first, because it says W must be greater than this power, but less than this power. And finally, to finish the last part of this problem, it says, what is the corresponding value of delta? So if we scroll back up, knowing that our target wattage was 33.22, what we need to do is subtract each value from 33.22 to get our possible values of delta, and then pick the smaller one. So we're going to do 33.22 minus 33.10, and as a decimal, 0.12. So we're going to say delta 1 is 0.12, and then delta 2 would be 33.33 minus 33.22, which is 0.11. And then you just simply pick whichever distance is smaller, and that is your value for delta. And so entering our value 0.11 that we suspect delta is, let's submit and see if our remaining answers are correct. All right, everything looks good. And so that's going to do it for this problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.